If your bot keeps forgetting earlier messages or your context window explodes, you need proper session memory. We will build a simple history store and truncation rules so conversations stay coherent and cheap. You notice the problem in real life when the assistant asks the same question twice or when every reply becomes expensive. I will show you how to store what matters, drop what does not, and keep replies personal without wasting tokens. By the end, you will understand a minimal session memory pattern you can extend to real systems. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced, with simple, concepts-first Python that helps you solve bigger real-world problems. Session memory in Chatbots is about two things: the recent conversation history and the durable state you carry across turns. The pain point is simple. Models only see a fixed context. If you naively send every past message, cost and latency grow. If you send too little, the bot forgets identity and earlier decisions. Success is a prompt that keeps enough context for coherence while staying small enough to be cheap and fast. At a high level, you want 3 behaviors. First, collect turns as they happen. Second, measure or estimate the payload size. Third, compact the history by pinning facts and trimming older chatter. That gives you a small, repeatable prompt you can send to any LLM. Strengths are predictability and low cost. The weakness is that aggressive trimming can remove helpful nuance. We will build a tiny demo that shows growth, cost estimation, windowing, state pinning, and a compact prompt assembly. Nothing fancy, just clear steps you can adapt. Think of it as a clean baseline for every chatbot project, so the code feels friendly before you deep dive. Now we will create and grow a simple message list. This snippet builds a tiny chat history and crafts a context-aware reply. The list messages holds role text pairs in order, starting with a system instruction and a username declaration. A follow-up user question is appended, asking for their name. The assistant reply uses the earlier user message by splitting its text and taking the last word as the name. Appending both the question and the answer shows how a session grows with each turn. The result reports the total turns now stored, which reflects how much context you could send next. Read top to bottom and you will see how a single extracted fact can be reused to personalize replies without reprocessing the whole history every time. Next, we will estimate how big that session is in token-like units. This snippet estimates token cost for the whole session against a budget. The variable toke sums word-like tokens by splitting each message text, which is a fast proxy for actual LLM tokens. The variable budget represents your target context size, and over indicates overflow beyond that limit. This quick tally helps you spot when naively sending everything will waste tokens or risk truncation. Increasing budget reduces over. Decreasing it increases pressure to trim. The printed total shows the payload size you'd currently ship to the model. Use this quick proxy during development to set sane defaults before you measure real model tokens. Now we will compare full history with a sliding window. This snippet compares full history versus keeping only the last n turns. The variable n sets the window size, and slicing messages -n selects that recent window. Two sums estimate total tokens for all messages and for the window. Then saved captures how many tokens you'd avoid sending. This highlights the trade-off between coherence and cost. Increasing n keeps more context but saves fewer tokens. Decreasing n trims harder and saves more. The printed saved value quantifies how much context you avoid transmitting. Sliding windows are the cheapest baseline and a great fallback when you do not yet have an extractor for durable facts. Next, we will pin stable facts into a compact state object. This snippet pins durable state to replace older turns and shrink context. The variable state holds stable facts extracted from history. Here, the username taken from the earlier introduction. The list keep constructs a compact context. Always keep the system message, include a single state line, and keep only the most recent user message. This maintains identity while dropping redundant older exchanges. If you kept more recent turns, tokens would go up. Fewer turns reduce cost further. The printed kept count shows the trim size after compaction. Pinning is what lets you remember who the user is without resending every greeting. Finally, we will assemble a small prompt to actually send to the model. This snippet assembles a baseline prompt with system, pin state, and recent turns. The state dictionary keeps key facts like the user's name, so you don't resend older messages. The list pref is the fixed prefix, and cell adds the last two messages to preserve immediate context. This creates a small coherent prompt you can send to an LLM while controlling cost. Adjust how many recent turns you include to balance coherence and latency. The printed token count confirms the final prompt's compact size. This is the pattern you will reuse. Prefix plus pinned facts, recent turns. In a real application, you would replace the toy name extraction with a small parser or a single named entity call, and you would compute the token proxy with the model tokenizer. The same pattern maps to customer support, Turing bots, and session-based automation, where identity and recent instructions matter. Recap. What it is: a lightweight session memory combining recent history and pinned state. When to use it: whenever you need coherent, personalized chat without blowing your context budget. One caveat: overly aggressive compaction can lose important context, so validate quality as you trim. Next step: tune the window size and the set of pinned keys. Measure reply quality and token cost as you change the window, and pick the smallest prompt that preserves the behavior you want. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.